Hi everyone, welcome to the Pre-Cal 40S videos. We're going to start off in Chapter 1 with transformations and functions, which covers all of these outcomes you see here. First thing we're going to do is we're just going to review domain and range a little bit. So grab your booklets and let's go. So if you recall, domain and range looks at X values. So the domain looks for the X values that are involved, and the range looks at the Y values that are involved. And just a little review of what set notation and interval notation is. I'll first do a little bit on set notation. This is the one where it had like the curly brackets and you had a statement, X is such that, and then you had something like X is greater than 5, and then X belonged to the element of the real number system, right? So an important thing to remember here is that when you have these greater than, less than, equal to symbols, that is where the number is included. And when they are not included, you don't include that little line underneath. All right, now for interval notation, this is where we simply write the interval of the numbers that are involved. And that would look something like this, would be you would only look at the numbers that are involved. So we'd have 5. Now 5 isn't included. So then we put a round bracket there, and then it goes all the way to infinity. And we put a round bracket on infinity because we don't know what infinity is. We can't really count up to there. So we're not really going to include any last number. So just let you know about the square brackets. The square brackets, you've listed the number that's included and the number that's included. So square brackets are for numbers that are included, and the round brackets are for the numbers that are not included, and you'd have a bracket in the middle. So, all right, now let's do the first example and concentrate. First, we're going to look at domain, and we look at the X values that are involved. So here you can see I go from -6 to 6. So the numbers that are involved are -6 is the smallest number, and the function, or the relation in this case, is including 6 and -6. So it goes from -6 all the way to 6, and we have a filled in circle there, so it stops there, and they're both included. Now, let's look at the range. The range goes from -4 is the smallest value, and +4 is the biggest value. So we're going to say -4 is included, and we put a Y in the middle there because we're talking about the Y's. Now, if we look at this in interval notation, this is -6 is included, and it goes up to +6. And here, same thing, just with the 4s. All right. Now let's have a look at this. You notice that there are arrowheads on both ends. That means it's continuous. It keeps going up this way to positive infinity, and it keeps going down that way to negative infinity. That's if I'm looking at my, so now we need to separate and look at the X values and the Y values. So what is it doing? So in that direction, it keeps going, which is the X's. So we'll just say X is an element of the reals because every real number is included. And same for Y. Y is an element of the reals. So the Y values, it keeps going up that way. Okay, so in interval notation, what this looks like is I go all the way from negative infinity to positive infinity, and infinity gets round brackets because they're not included. And the exact is the same for the Y's and the range. All right, so domain of this guy. So here's a parabola. It's shifted 1 unit up, so my smallest value here is a 1, and that's on the Y values. For the domain, I think I started talking about one before the other. For the domain, the X's, they're going to keep going that way, right? When these two arms kind of spread and keep going. So domain here in this case is X is an element of the reals, and my Y values, everything's shifted up 1 unit, and you notice that there's no graph below the 1. So 1 is the smallest value, and everything is bigger than 1. And if we look at interval notation, we've got negative infinity to infinity here, and we have 1 is the smallest value. It is included, so I put a square bracket, and it goes up to positive infinity with a round bracket. And for this last example here, the domain, well, we need to look at the x values that we are allowed to input. And if you notice here, you have 1 over x. So remember, we're not allowed to have a 0 in the denominator. So we've got x is not allowed to be 0. Okay. Now, as a result of that, if you were to try to look at the range, so we're looking at the y values, so what do you notice is never going to happen here? Because we can never actually make this 0, there's no possible way that you could make this y a 0. And you've got an asymptote here, right? These lines, they approach the 0, but they're never actually going to get there. So your range is also, in fact, y cannot be 0. Now this, in interval notation, is a little unique. We need to look at what we're not allowed to do. What we're not allowed to do is here, but in interval notation, we're looking at what are we allowed to do. So we've got negative infinity. We can go all the way up to 0, but we can't actually get to 0. And we need to talk about the positive infinity side, right? So here we've got 0. It's not allowed to be 0, but it can go up to positive infinity. So since we have these two statements, we need to put a little union symbol there. That means that we're able to do both. All right. So we're taking account for these positive x values greater than 0 and these negative x values less than 0. All right, and so our range ends up looking exactly the same, okay? All right, so this, again, that's a union. So if you want to think of layman's terms, it means and. All right. So the next thing we're going to do is we're going to look at these basic functions and their graphs. We're going to call these parent functions. I'm going to call these parent functions because these are everything. It kind of starts from here, right? So this is the basic linear function. That's the quadratic. We're looking at the reciprocal and the radical, absolute value, cubic, and the trig functions, sine, cosine, tan. You need to be familiar with these in order to have a bit of an easier time doing the questions that we're going to be asking. All right. And just to review the strategies for graphing, we are going to remember from back in the day that, well, when we started, we could make a table of values and plot the points. Okay, so we also were, at one point, we looked at x and y intercepts. And we looked at asymptotes. Okay, and I forgot a T in there somewhere. And also we looked at key points and we graphed key points and then connected all the dots. New notation that we're going to be looking at is mapping notation. This is where it describes the relationship between the original points and the new points. So let's say, for example, our original points are x comma y, and then this is going to show you the path of how we got to the new x value and the new y value. All right. And for a new definition here, we've got for transformation, this is what we're going to be doing. We're going to be transforming graphs. This is a change made to an equation such that the graph of the function or relation also changes. So a change made to an equation such that the graph of the function or relation also changes. Okay, so that's the end of this video. We're going to continue with the 1.1 notes on the next one. So see you soon.